Hello everyone. Today we are here to learn about the generation and hazards of lightning. Through the study of this course, we'll help you understand how lightning is generated, classification and hazards. Understand the types of lightning over voltage. Lightning disasters have been classified by the United Nations as one of the 10 most serious natural disasters and have become the third largest meteorological disaster after rainstorms and floods and landslides. Serious threat to human life and property safety when building and electrical equipment are struck by lightning. The discharge voltage of lightning is much higher than the power supply system's normal value. It is extremely destructive. Lightning can cause human and animal casualties, damage to buildings, electrical line outage, and damage to electrical equipment. Even cause serious accidents such as fire and explosion. Therefore, the study of lightning generation pattern and then take effective protective measures to prevent the damage caused by lightning has important significance. First, the formation of lightning. Lightning is generally generated in convective development of strong cumulonimbus clouds. Therefore, it is often accompanied by strong gusts of wind and torrential rains, sometimes accompanied by hail and tornadoes. The formation of cumulonimbus clouds in the late afternoon or evening of summer. Hot air from the ground carries large amounts of water vapor and rises to high altitude. In the air, different cold and hot air masses meet and condense into water droplets or ice crystals, forming large-scale cumulonimbus clouds. The tops of cumulonimbus clouds are usually high. Different parts of the cumulonimbus gather large amounts of positive or negative charge up to 20 kilometers. Ice crystals are often found in the upper part of the cloud, forming thunderstorm clouds. The freezing of ice crystals, the breakup of water droplets, and air convection processes creates an electrical charge in the cloud. Thunderstorm clouds. The distribution of charge in clouds is complex, but in general, the upper part of the cloud is dominated by positive charges. The lower part of the cloud is dominated by negative charges, and the ground is subject to electrostatic induction from near-ground thunderstorm clouds. We'll also take the opposite polarity of the cloud bottom chart. The two are equivalent to a huge capacitor when the strength of the electric field formed by the thundercloud reaches a certain value, and the insulation of the surrounding air is destroyed. Between positive and negative thunderclouds or between thunderclouds and the ground, a strong discharge will occur. Pilot discharge. When a positive or negative thundercloud between the thundercloud and the earth in a certain orientation, the electric field strength reaches 25 to 30 kilovolts per centimeter. The air insulation breaks down. The thundercloud will begin to discharge in this direction, creating a conductive air channel, known as a lightning pilot, where the Earth's anisotropic charge is concentrated above the tip of the lightning pilot. 100 to 300 meters above the ground also forms an upward-facing lightning pilot. The upward and downward leads meet, creating a strong discharge, forming the main discharge channel. Glow discharge. The residual charge in the cloud comes down through the main discharge channel and neutralizes with the charge on the ground. This is called the glow discharge process. The current in the globe phase is small, but lasts for a long time. Second, overvoltage and its classification. During normal operation, power system equipment insulation is rated voltage. Affected by various factors, the actual voltage will deviate from the rated voltage by a certain value. Generally speaking, power system operating voltage under normal conditions will not exceed the maximum operating voltage. But due to lightning strikes or power system operation, accidents, and other reasons, make some electrical equipment and circuits are subjected to a voltage much higher than the normal operation voltage. Jeopardize the insulation of equipment and lines. In the power system, this kind of voltage increase that jeopardizes the insulation of electric equipment is called overvoltage. Generally, power system overvoltage is divided into lightning overvoltage and internal overvoltage. Lightning overvoltage is caused by sudden cloud discharge or lightning induction caused by the overvoltage related to meteorological conditions. It is caused by external causes. Therefore, it is also called atmospheric overvoltage or external overvoltage. Internal overvoltage is caused by the power system's internal electric-magnetic energy transfer or transformation. With the internal structure of power system, parameters, operating conditions, power outage and feeder operation, and the occurrence of accidents and other factors, it is very complex. For example, the opening and closing of circuit breakers, dramatic load changes, line breaks, short circuit or ground fault may cause internal overvoltage. Third, lightning overvoltage classification. Generally, the lightning overvoltage of the power system is divided into direct lightning overvoltage, induced lightning overvoltage, lightning intrusion wave overvoltage, direct lightning overvoltage. Thundercloud strikes a house directly, pole and tower, when an objective, such as an electrical installation, a strong lightning current flows through the object and leaks into the earth. A very high voltage drop is generated on the object. This is called direct lightning overvoltage. Induced lightning overvoltage, when lightning strikes the ground near equipment or overhead lines. Equipment due to electrostatic induction and electromagnetic induction, overvoltage is generated on the equipment, is called induced lightning overvoltage. Overhead lines in the vicinity of one where is the lightning strike to the ground, induced overvoltage can easily occur. When a thundering cloud appears above an overhead line due to electrical static introduction accumulates a large number of anisotropic bound charges when the thundering cloud discharges to ground, or neutralization of other anisotropic thundering cloud discharge. The bound charge on the line are released, and a free charge is discharged to both ends of the line. A very high induced overvoltage The induced overvoltage on a high voltage line can be as high as hundreds of thousands of volts. Induction overvoltage on low voltage lines can be up to tens of thousands of volts, harmful to the power supply system. Lightning overvoltage. Thunderclouds clouds on overhead power lines. The top of the tower or a thundercloud cloud discharges on the lightning conductor. The top of the lightning conductor. When the lightning current flows through the tower to earth, there is a voltage drop across the tower impedance and grounding. Device impedance. Therefore, there is a high potential at the top of the tower. This high potential acts on the line's wire insulators. If the voltage is high enough, there is a possibility of breakdown, discharging the wires. This is called a lightning strike over voltage. Lightning incursion wave over voltage as a result of a direct or induced lightning strike in transmission line conductors forms a rapid flow of electric charge. It is called a lightning incursion wave. The surging voltage generated by a lightning incursion wave to electrical equipment in its path form a threat. That's why it's also called a lightning incursion wave. It travels at a speed of 300 meters per microsecond, 150 meters per microsecond in a cable line. In a typical substation, if there are overhead access lines, it is necessary to consider the prevention of lightning incursion wave. The serious threat of lightning incursion waves to electrical equipment is also a serious threat because when the lightning incursion wave travels forward, for example, when it encounters a line switch that is open, or at the neutral point at the end of a transformer coil, a total reflection of the wave occurs. This reflection is added to the intruding wave, doubles the overvoltage. It is very easy to cause a breakdown accident. Fourth, lightning hazards. Finally, let's learn about the hazards of lightning. Lightning releases a large amount of energy. It produces a strong current, scorching heat, violent shock waves, fusion of electrostatic fields, and strong physical effects such as electronic radiation have brought a terrible disaster to the human society, especially electronic communication, microelectronic equipment, and highway traffic electromechanical system. The harm of lightning electronic pulse is especially obvious. In a sense, the more advanced the technology, the greater the impact of lightning strikes on people. First, electrical hazards. For electrical equipment, the high voltage effect of lightning current will produce up to tens of thousands of volts, even hundreds of thousands of volts of shock voltage. Such a huge voltage instantly shock electrical equipment, enough to break through the insulation and short-circuit the equipment, causing widespread power outages, resulting in combustion, explosion, and other direct disasters. For people, risk of electrocution, huge lightning currents flowing into the ground can directly cause electric shock due to contact voltage or step voltage. During the thunderstorm season, in the vicinity of lightning strike points and lightning rod grounding points, hazard of electric shock with step voltage. Second, thermal hazard. Thermal hazards are when lightning strikes an object and causes the object to develop a very high temperature and melt. Vaporization, combustion, and other phenomena. High temperature directly cause fire or explosion. The high heat effect of lightning current will release tens to thousands of amps of strong current and generate a lot of heat energy. When lightning current passes through conductors with resistance or inductance, produces a high level of heat, destroys the insulation of electrical equipment, causes metal to melt, generates sparks and discharges, causes combustion and explosion. Third, mechanical hazards. Mechanical effects of lightning current. The main manifestation of the object struck by lightning is damage, explosion, distortion, collapse, tearing into pieces. When lightning strikes a tree, the strong electric current that passes through the tree generates, causing the water in the tree to vaporize, to form hot, pressurized water vapor. These gases expand rapidly against the tree, which split the tree. Fourth, lightning induction. Lightning current electrostatic induction could make conductor of the struck object to generate a large number of charges opposite to the nature of lightning. When the lightning disappears too late to disperse, that will produce a very high voltage discharge phenomena, so that the objects in the water quickly vaporize. These gases quickly expand and burst. In addition, electrostatic repulsion, electromagnetic force, impact on the gas wave makes the bursting hazard increased. Fifth, electromagnetic induction. Electromagnetic induction of lightning current will be around the lightning strike point, generate a strong alternating electromagnetic field. The induced current can cause localized overheating of electrical equipment and lead to fire. 6. Lightning intrusion wave. The intrusion of lightning wave and lightning protection devices on the high voltage on the building of the counterattack effect can also break through the insulation of electrical equipment, causing short circuits in power distribution devices or electrical circuits, which can burn and cause a fire. This is the end of this course.